Welcome back to NM Serena. In this video, we are going to discuss the weighted price index numbers. Before moving to the weighted index numbers, let us see what all are the methods available for the construction of price index numbers. One of the simplest method is symbol aggregative method. Another one is weighted aggregative method. Then symbol average relative method and weighted average of price relative method. Among these methods, two methods are unweighted methods and two methods are weighted methods. The unweighted methods have already been discussed in another video. So, in this video, we are going to discuss the two weighted methods for calculating or the construction of price index numbers. Now, we have to know what is a weighted index number. In weighted index numbers, weights are assigned to various commodities considered in the construction of that index number. These weights can be quantity weights or value weights. Then what is a quantity weight and what is a value weight? The quantity weights are the amount of quantity consumed, produced or distributed, whereas the value weights are the product of price and quantity consumed, produced or distributed. The weighted index numbers may be constructed using weighted aggregatives method or weighted average of relatives method. Both these methods are discussed here in this video. First of all, let us see the weighted aggregative method. In this method, appropriate weights are given to different commodities to show their relative importance in the group. For price index numbers construction, quantity weights are used. Different types of weighted aggregative methods are available, and a few of the important methods are discussed here. One of the most important weighted aggregative methods is the Laspeyres index number. The Laspeyres index number was developed by French economist Laspeyres in 1871. This is done by taking the base year quantities as weights. The formula here is sigma P1Q0 divided by sigma P0Q0 into 100. The next one is Paget's index number. And the case of Paget's index number, the formula given is sigma P1Q1 divided by sigma P0Q1 into 100. This formula was given by a German statistician Paget in 1874. In this method, we are taking the current year quantities as weights. And the next one is Fisher's index number. Irving Fisher advocated the geometric mean of the Laspeyres formula and the Paget's formula to find the Fisher's index number. It is also called cross-weight formula. And the Fisher's index number is the ideal index number as it satisfies both the time reversal test and the factor reversal test for the consistency of index numbers. Now the formula is square root of sigma P1Q0 divided by sigma P0Q0 into sigma P1Q1 divided by sigma P0 Q1 into 100. Now, this is a combination of Laspier's formula and Pachet's formula. This part of the formula is Laspier's formula and this is Pachet's formula. So, it is actually square root of Laspier's formula into Pachet's formula into 100. Now, the next formula is Dobbish and Bowley's index number formula. And this method is also sometimes called LP formula because this index number is the arithmetic mean of the Laspier's and Pachet's price index numbers. Since Laspier's formula takes into account base year weights and Pachet's current year weights, the Dobbish and Bowley take the impact of both base year and the current years. The formula here is sigma P1Q0 divided by sigma P0Q0 plus sigma P1Q1 divided by sigma P0Q1 divided by 2 into 100. Now, among all these formulas, Fisher's index number is the ideal index number formula. And the next method is Marshall-Edwards index number. This formula is just like that of Fisher as it involves the use of current year as well as the base year prices and quantities. Of course, there is a slight difference in the results obtained from the Fisher's formula and this formula. But this formula is preferred sometimes because it is relatively easy to compute. It does not use the difficult calculations of the geometric mean and all. The formula is sigma P1Q0 plus sigma P1Q1 divided by sigma P0Q0 plus sigma P0Q1 into 100. And now the next formula is given by Kelly. Kelly's index number. This formula is named after Truman L. Kelly. It takes into account the weights to be fixed for all periods and is also known sometimes as aggregative index with fixed weights. It is given by the formula sigma P1Q divided by sigma P0Q into 100. Now the various components of these formulae are P1, the current year price, and P0 is the base year price, Q1 is the current year quantity, Q0 is the base year quantity. These are the different components used in all these formulas. In addition to that, Kelly's formula uses Q value. That Q is equal to Q0 plus Q1 divided by 2. Q0 plus Q1 divided by 2. That is the average of the base year quantity and the current year quantity is taken as the weight in Kelly's formula. Now, we said that Fisher's formula is the ideal index number for calculating the price index numbers. Now, why is it so? The answer to this question is that Fisher's formula is based on both base year and current year price and quantity. Another one is that it is a geometric mean of the Laspier's and Pachet's index numbers. And the formula also satisfies both the time reversal as well as the factor reversal tests. That is why Fisher's formula is considered as the best one among the weighted index numbers. And now let us see how this is applied in a problem to find the index number. Suppose the items are given as A, B, C, D. So there are four items and the P0, that is the base year price, is given. P1 current year price, Q0 base year quantity, and then Q1 current year quantity. All these values are given. We have to see which method has to be used here. A suitable method had to be find out before applying a formula. See, suppose the Q0 column was not there. If the Q0 column was not there, then it is not possible for us to use the Laspier's formula because that formula requires Q0. In addition to Laspier's formula, we are also not able to use the Fisher's formula, Dobish and Bowley's formula, Edgeworth formula also. All this formula cannot be applied if Q0 is not there. Similarly, if Q1 was not there, again we cannot be we are not able to apply the Pasch's formula because that required Q1. We cannot apply Fisher's formula that also requires Q1. We cannot apply Dobish and Bowley's formula that also require Q1. We cannot also not apply Marshall and Edgeworth formula because that also required Q1. Hence, we can apply only Laspier's formula if Q1 is not there. But in this case, everything is given. P1 is there, P0 is there, Q1 is there, Q0 is there. So we have to use the most appropriate formula using all these values if the question asks us to find an appropriate method. Here we can find that Fisher's method is the most ideal method under the weighted index number methods. So we can try to apply the Fisher's method and all the components of Fisher's formula are present here. Now we have to calculate certain values for applying in Fisher's formula. Those values are P1Q0. P1Q0 means P1 into Q0. P1 values into Q0 values. 7 into 10 is 70, like that. P1 into Q0. And the sum of that is 272. Sigma P1Q0 is 272. Another value is also required for Fisher's formula as P0Q0. That is P0 values into Q0 values, we get this column. And the sigma P0 Q0 is 180. Another value required for Fisher's formula is P1 Q1. P1 values into Q1 values, and the sigma P1 Q1 is 218. One more value is required. P0 Q1. P0 values into Q1 values gives the P0 Q1, and sigma P0 Q1 is 146. Now let us see the Fisher's formula. Fisher's ideal index number is equal to square root of sigma P1 Q0 divided by sigma P0 Q0 into sigma P1 Q1 divided by sigma P0 Q1 into 100. So this part of the formula is Laspier's formula and this part of the formula is Pasch's formula. So it is a combination of Laspier's method and Pasch's method. Square root of Laspier's method into Pasch's method into 100 is the Fisher's method of finding index number. Now let us apply the values in the formula. See, sigma P1 Q0 272 is put here, then 180 sigma P0 Q0 218, that is P1 Q1, and then P0 Q1 146, all are applied and square root of these values, and after that into 100. Now on computing this we get 1.5021 into 100 and the final answer is 150.21. 150.21 is the index number according to the Fisher's formula. And the next method under the weighted method of calculating price index numbers is weighted average of price relative method. Here the formula to be used is index number is equal to sigma IV divided by sigma V. I is P1 by P0 into 100. That is, for each item we have to find P1 by P0 into 100. Then V is the weight. And now let us apply this formula in a problem. 5 items are given A, B, C, D, E, and the weights are given. Price in 2008 is given. Price in 2009 is given. So if no other information is given, we are going to take the recent year as the current year, that is 2009 in this case, and the back period as base period, that is 2008 in this question. Now here we can apply this formula sigma I V by sigma V. For applying that formula, we have to find the I value. I is P1 divided by P0 into 100. This is P1, this is P0. So, for each item, we have to find P1 by P0 into 100. 20 divided by 16 into 100 is 125. 60 divided by 40 into 100 is 150. Like that, each item has to be found out. Next is IV. These I values into weight. This is V. In the question, the weight is given, so that is V. So 40 into 125 is 5000 IV. Like that, we have to find I into weight as IV column. Then we have to apply it in the formula. Index number is equal to sigma IV divided by sigma V. That is, this 12,150 divided by the weight 100 divided by 100. And the answer is 121.5. 121.5. And that's all about the weighted index numbers. We have seen the importance of the weighted index numbers in the construction of the price index numbers in this video. And the unweighted index numbers have been discussed in another video. Thank you for watching this video. For more videos, subscribe the channel.